Sir, should I start recording? Sir, you are mute.
Very good morning to all. Yes, I was mute. Thank you. Today, as per our every day, every Saturday's lecture series, we have one very important topic related with force measurement using destructive and non-destructive methods. We have with us Dr. Surya Kumar Gautam, who is a senior scientist in force, torque, and hardness metrology at National Physical Laboratory, New Delhi. He's an engineer by profession, done MTech, PhD from IIT and Institute of Space Science and Technology, Trivandrum. He has written large number of research papers, journals, and has a lot of professional experience. Thank you, Dr. Gautam, for accepting our request and delivering a talk on this topic. Thank you very much. We have with us our Honorable Shri B.N. Dikshit, our Director Legal Metrology, sir. Sir, would you like to speak two words, please?
Yes, Ashutosh ji.
Please, sir. Over to you, sir. Please.
So, very good morning. Sri Ashutosh Agrawal ji, Director Legal Metrology, Government of India. Dr. Surkumar Gautam ji, today chief guest of the program. The topic is related with the sensor, and sensors plays very important role in particularly the legal metrology and other fields also. Its expansion has not been done. People are only thinking for the weighing and measuring instrument and some other things and bit related technologies. So load cell, you know very well that it is very well used for the measurement of electronic weighing and measuring system. Basically, load cell is made of the strain gauges, and then various type of load cell are there. Some are the compressive types, some are the other non-compressive types. So this is for this. Apart from that, there are the electromagnetic force compensation principle and some tuning fork technology is there. So many other fields are there also. All these things are related with the torque measurement and the force measurement also. So when the people are doing the force measurement, so there also you'll find the big mass surrounding the round shape of type of things for the measurement of the force, but it is uh, derived in the Newton. So the technology is the same, only the unit is different. So that way the force measurement is done. NPL is having the lot of facility for the measurement of the load cell, torque measurement, and this force measurement also. These facilities are also being available in our regional reference standard laboratory, where the peoples are being well benefited. Apart from that, the Director Legal Metrology has given lot of lecture throughout the country, by which the industry has been benefited and they are using the different type of load cells. I hope that Director Legal Metrology will take the initiative for Make in India so that the most of the peoples may do this manufacturing of the load cell and related type of things, because this is the work of the small scale industries. A lot of initiative of the Prime Minister is there. So that may be taken along with this very work there. So much industry will be benefited. But it should be encouraged from the director legal methodology, only then the people will come there. Because when the encouragement is not there, people will think that there is a hurdle from the government and all that very things. There is no hurdle in the measurement of the load cell, in the manufacturing of the load cell and related items. So I think that the direct legal methodology will take the initiative and the industry people will benefit it. Even it is good for the student also, they will know about that very things. And if such type of topics is discussed on most of the Saturday and lot of the things related item, so industry and student will be benefited and they will start their own businesses. And from that very businesses that our country will grow. Because at present the Prime Minister has taken initiative for the Make in India. So he's forcing for Make in India due to some international reasons. Very times our initiative is very important, and I hope that Asutosh Agrawal is a very good leader, and he will take the initiative, and the peoples will benefit it. Thank you this much. The rest of the things will be discussed by Asutosh Agrawal ji and Dr. Uh, Surya Kumar ji, and give his lecture, and then what the initiative may be done on that very things also the matter will be discussed. Thanks a lot.
Thank you, sir. Thank you very much for your kind and motivating words. Thank you very much, sir. Thank you. We are always obliged to listen you, to hear you. Thank you very much, sir. Kindly be with us like this. Thank you. Thank you, sir. Thank you. Over to you, Professor. Dr. Surya
Yeah.
Kumar Gautam. Over to you.
Yes.
Please, sir.
Yeah, good morning all actually, and thank you for this wonderful opportunity. I'm deeply grateful for this kind invitation to deliver a talk and for this wonderful opportunity. I truly appreciate actually the chances to share my experience and learn from the interaction I have. So I will, without any further ado, I think I will start my presentation, right? Okay. So wait. So, title of my presentation is basically force measurement using destructive and non-destructive testing. And once again, good morning all. And my name is Surya Kumar Gautam. I'm working in CSIR National Physical Laboratory in Force, Torque and Hardness division basically. And in today's talk, these are the points which I will discuss, like introduction, then importance of force measurement, force realization, then effect of force, and then destructive and non-destructive testings, and then outcomes. Like that way, we will proceed. Okay, so first let me start from the basic. Uh, what is force basically? Force is a push or pull exerted on a object that can cause it to change its motion or direction or shape. So that is basically a force. It can be in push or pull direction, and its nature is basically is a vector quantity. It have both the magnitude as well as the direction. I hope my cursor is visible. Is it? Hello.
Yes, sir.
Yeah, my cursor is visible.
Yes. Cursor is visible. Very well. Very
Okay.
well. Please.
Okay. And okay, so then the type of forces is contact forces, which will be like friction, tension, compression, normal forces, applied forces, and some non-contact forces also there, which we can just experience, like gravitational force, magnetic force, electrostatics force, etc. All right. So before going deep into the force measurement, we will start from the importance of force. Why it is important to measure the force, basically. So let me give you one example. Suppose a industry want to build a lift, okay, and most of you might have seen like inside a lift, it is mentioned like the weight limit is 500 kg and only 5 to 6 or 6 to 8 people are allowed, like that you might have seen, right? So from where actually those industries are getting this value? Okay, it could be maybe because it is for safety purpose, but uh, to write that value, they might be doing some kind of testing initially when they are fabricating this lift structure. Okay, and to perform the testing, like at what value this lift will break and sustain the weights, they need some kind of machines to generate the force. Okay, so okay, now the question come, whatever force machine they have, their values is correct or not, how they know that? So that come now come the role of a force sensor. So force sensor, what basically it does, it whatever machine randomly is generating force using maybe some kind of hydraulic mechanism or some kind of motorized mechanism, they can generate the force randomly, like in increasing order or decreasing order. But they need some kind of instrument which can check the uh, that force value, and whether that instrument is giving the correct value on it. First they need to calibrate that load cell. So as a NMI of India, NPL is basically providing the calibration facility, and especially our group providing the calibration facility in force, torque and hardness. So we are basically receiving the load cells, or sometimes they call it as force sensor or force transducer, or simply as a load cells. So we are getting the load cell from all over the countries, and we are doing the calibration. So calibration is basically, suppose that load cell is basically kind of black box. Whatever we are applying the force, it is giving some kind of reading. But initially, without the calibration, that reading has no value. So we need to apply some known forces, and that known forces we can apply using some standard machine which have we in the NPL. Okay, so the calibration means we have to apply some known force value to the transducer, and that transducer will get the calibration. So after that calibration, we know the response of the transducer, like at what force value it will give what kind of reading, and that reading will corresponding to what value exactly of force. So that is the calibration. We are basically assigning the value to the load cells. Okay, now the once the calibration is done, the response of the transducer we are giving back to the industry, and that
Excuse me, sir. You are on the third slide only.
yes.
Okay.
Yeah.
Please.
Yeah, so okay, so the industry is basically then using that calibrated load cell in their construction site, and they are basically then doing the all kind of testing and calibration to the machines. So like that way, the traceability and the calibration is performed. Okay, that is a one example of making the elevator lift. We can I can give you another example in precision in medicine and healthcare, which is very much important when we are talking about the force measurement. So you might have seen, like in all kind of medicines, in backside it is written this chemical is this much milligram, and another chemical is this much milligram. So from where they are getting those value? Again, the same thing actually. They are having some kind of precision weight balance, and inside the weight balance, load cell is there. So again, they will send that load cell to us. We will do the calibration, and we are giving back that load cell to the industry who's making the weight balance and so on for using in the healthcare industries. Another example is like in gold and jewelry, force-based weighting system ensure precise mass measurement for fair trade and certification. So trade means we can country-wise also trade can happen. In that also, this force measurement is playing very important role. And another is industrial and structural safety in applied in bridges, crane, and machinery to avoid structural failure and maintenance operational safety. So all these is very important. For that, we need a force measurement system. Hope it is clear till now. So we will move forward. So in NPL, basically to realize the force is a vector quantity, and we need to have uh, mass and gravity to realize a force. And mass should be kept vertically when we are applying the forces. So this kind of machine we are using, these have these dead weights. Dead weight is called because they are not moving, and this masses stack is connected with the periphery or from the center node, like as you can see, and one by one we can select or we can remove the weights, and the load cell, which is a force transducer, is kept in this frame. So this frame is connected to the weights. So one by one we can increase or decrease the weights depending on our need, and we will get the readings from this load cells. So like that way we are applying the force, because manually we cannot apply. If it is a small force, we can apply manually also, but if it is very uh, like force in the high range, then we need this kind of machines to apply the force very accurately, because it's a vector quantity. So the frame and this masses stack should be kept vertically aligned perfectly, right? So this is how we can realize the force, and it is called the force deadweight machine. Another important thing is this height of this machine is, like, suppose if you want to design a 100 kN force machine, then height will be almost like a one-story building. So if we want to apply a 1000 kN, then it will be 10 times of that. So means 10-story building it will come if we go using this method. So what generally people prefer is some kind of mechanism, like to amplify the force value. So they are using lever multiplication or hydraulic multiplication, like this. So we will come back to that later. First let me talk about the lever multiplication. So in lever is simple, a lever arm is there, and we will support it at the some point which is not at the center, and based on this length ratio, this L1 and B, uh, if we are applying force at one end, and force at the F2 means at another end will be multiplied by this equation.
I'm sorry, Dr. Gautam. We are still on the third slide only.
Oh, sorry. Is it moving now?
Yeah.
Okay. Okay, I will explain once again. This force realization, basically we are using this kind of machines, and we have several masses, and which is connected to the frame, and frame, in between the frame we have to keep the load cell which is under calibration. Is it clear now, this slide?
Yes, yes.
Okay. So using this machine, one by one weights we can select and remove, and the instrument we can calibrate. So we call this kind of machine is a dead weight force machine. So basically this dead weight kind of force machine is suitable in, let's say, up to 100 kN, because its height is kind of one story building. So if we want to have higher value of force, then if suppose if we want to have up to 1000 kN force value, then height of this machine will go up to 10 story, which is very huge, and it is very difficult to handle all those weights. So what people prefer is lever multiplication, some kind of amplification mechanism to amplify the force value without using too much weights. So okay, so what they will do is they use simple lever structure, and they will support it at some point which is not at the center, and based on this length ratio like L1 and B, they can amplify force value from F1 to F2 using this simple formula. So at the balance condition, F1 into L equal to must be equal to F2 into B, and negative sign is there because if it is in downward direction, the F2 will be in upward direction. So like that way they can amplify the force using the simple lever amplification mechanism. And one of our primary machine is based on this principle. So you can see in one side we have dead weights. This is up to 100 kN, and person height you can see it is very it is mentioned here, which is this height of this machine is very big. And another side we will get the amplification 10 times. So this length ratio is 10 times. So we have 100 kN this side and 1000 kN this side force value. So this is the actual diagram of the machines, and lever ratio is 1 to 10. It is fully automatic force machines, and we can control the loading and unloading using a motorized controller, and calibration is performed using ISO, IS and AST, and it can be done in compression as well as in tension mode. And applied forces, if we are using this side, it will be up to 100 kN, and if we are using this side, it will be 1000 kN. And uncertainty is 0.002% in the deadweight side, and because this side the force is realized using mass, gravity, as well as the length. So one more factor is there. So because of that extra factor, uncertainty is high compared to the deadweight side. So people generally prefer the deadweight, but since we cannot go very uh, huge machine, so because of that, the lever multiplication is used, and we will get the uncertainty up to 0.009% in this case. Another mechanism is hydraulic multiplication. In this, actually, because the lever multiplication is also have some limitation, we cannot make force more than 10 times, because the length will be very big, and to handle that length again the bending can come, so many things can happen. So that method is suitable only for up to certain range. So if you want to multiply above that range, uh, there is another method called the hydraulic multiplication. In that, what we can do is force at one cylinder is, let's say, F1, and the smaller piston diameter is, let's say, area is A1, and the bigger side, the piston area is A2, and force is applied at F2. At the balance condition, uh, pressure at one end should be equal to pressure at the another end, because this liquid, whatever it is incompressible.
Sir,
So
still we are
force
on
at
sixth
the,
slide.
I don't know why it is not moving.
Can
Is
you
it moving
please?
now?
No.
Okay.
Now it is moving. It is
Okay.
seventh. Now it is eighth slide.
Okay.
No,
You can
please.
see
My
this
request is
pistons.
when you are changing the slide, now you kindly speak that next slide so that everybody will
Okay.
understand. Otherwise,
Oh,
your slides are
okay.
not moving, and you can just see in the left side. Na, it will be. It is very clearly mentioned which slide it is,
Okay, sir.
because it is not in the PPT mode. So you can see on the eighth slide, it is very clearly mentioned. Right now, you are at eighth slide. So you please check it.
Mhm. Okay, sir. Okay.
Thank you.
So this is hydraulic multiplication, in that we have two cylinder assembly. One area is small cylinder and another is bigger cylinder, and the cylinder area is A1 and A2. Okay. So at the equilibrium position, the pressure at one end should be equal to pressure at the another end. So pressure is basically F1 divided by the area A1 at this end, and another end pressure will be F2 divided by 2 A2. So at the equilibrium, this P1 should be equal to P2, and based on the area ratio, we can multiply the force value. So this method, actually, we have one machine in NPL. Here we are using a this hydraulic multiplication machine, and the area ratio is 100 times. So in the lever, we can increase force value up to 10 times. In using this method, we can increase up to 100 times. So this dead weight is up to only 10 kN, and we are multiplying with 100 times. So this side we are getting 1000 kN force value. Yeah. Okay. So next slide. So effect of force. Now you can see this slide, right? Effect of force. So what can force do basically? When we are applying the force, it can cause bending. Is it visible, sir? Right? Hello.
Is the way of this showing of slide. Can you make it
Effect
in
of
the
force
PPT?
is not visible.
Yeah, it is visible. It is visible. But can you make it
Okay.
in the presentation mode?
Okay. Wait.
Slides are very now for yeah. Now it is okay. Now it is okay. Continue.
Okay.
Please continue.
Okay. Okay.
Thank you.
So when we are applying the force, what can happen actually? Either the structure or whatever transducer is there, it can bend, or it can cause some kind of defect or deformation. Like if we are applying force, it can bulge like this, or it can displace. Like if we are applying force, it can displace. and or it can cause the change in the refractive index. Suppose if we have a transparent material like this, and if we are applying the force, what can happen is, if light is passing through this sample, it will experience a change in the refractive index due to the this force. And another important thing is birefringence. Birefringence is basically the dual refractive index. So if we have this transparent sample, if we are applying the force, the perpendicular and parallel polarization light will experience different refractive index. So that is called the dual refractive index. So that can change when we are applying the force, and they will experience different path delay due to that. So these kind of effect people generally use to design the force sensor. Okay, next slide is type of force sensor. So in the types, there are several type of force sensor. This is all destructive kind of thing, because we are using strain gauges, and we are pasting the strain gauges over the surface like that. So it is a contact and destructive method. So they have this kind of S type of load cell, button type of load cell, and this planar load cell, load pin or canister type of load cell. So there are several type of load cell is there, and all are using the same principle. Like they when we are applying the force, some kind of deformation will happen in the transducer. Now I'm on working of force sensor. Is it visible, that slide?
We are still on the same slide. Effect of force.
What about now?
Not
Not
changed.
moving.
Not yet. Can you unshare and again share? Yeah, now it is working of force sensor.
Yeah, I will do that, I think. Let's do it. Is it moving now?
No. It is first slide only. Can you put it on the presentation mode?
I did.
No, it is not in the
Not
presentation mode.
moving, right? I don't know what is.
Okay. Now working of force sensor. Please continue.
Okay. So in working of force sensor, when we are applying the force, it will cause some kind of deformation, and those deformation uh, we can sense using a strain gauges. So strain gauges is basically a kind of resistance whose resistance can be changed using a strain or stress. So those kind of strain gauges we need to paste over the surface of this kind of uh, structure, which is a structure of load cell, and it is configured in V-stone bridge configuration, and some resistance are fixed, and some of the resistance are replaced with the strain gauges. So at the balance position it will show no output, but when we are applying the force it will get disturbed, and we will get some kind of differential output from this strain gauges, and that is ultimately we can read using in some kind of digital indicator. So now I'm again working on force sensor, but in next slide. Is it visible now?
Oh.
Okay.
If you will
So
see the
when
left
we,
side now, if you will see the left side, it is just 12 slide only, which we are seeing. You just move in the
actually
left side. Yeah.
I'm not
Third
able
slide.
to see the this slide number. That is the issue.
Oh, you're not able to see your slides.
Slide numbers.
Okay, okay. But left side we are able to see properly. Anyway, I think this there is one another button at the above side which is share. You just share this in the right hand side, red button.
Uh,
Red button in the right side, share. Anyway, Dr. Pradeep
yeah,
Saini.
anyway, now I'm
Right.
able to see. I think this slide number also. It is 13 slide, right?
Yes.
Okay.
Yes,
So,
Dr. Praveen Sani, wish you speak, would like to speak something? You have raised your hands. Dr.
Yes.
Praveen Sani.
Yes, I just wanted to help him. Maybe you can unload the presentation, put it in the full screen mode, and then load it again. I think it will work out.
okay,
Yes, done
I
already
will
that.
check that also. Yeah.
But no, you have already done that, na? Unload and
Yes,
load.
I did that actually.
Unload, put to the full screen mode, and then load again.
If I put in the full screen mode, then I'm not able to share it, right? Sharing option will come only when it is not in the full screen mode. Anyway, hope it is
Use the
visible now.
Alt and Tab key. Use the
Yes.
Alt and Tab key to toggle between the windows. Then you will be able to load
Okay,
when it is in full screen mode.
okay,
Okay.
okay. If
What
it
you do
is
Alt
now?
stuck
and
like
Tab.
that, I will try one more time like
Please.
this.
Now you are on
Keep
slide
pressing the
number.
Alt key and then Tab. You will toggle between the windows.
Okay, I think
Okay,
it may be difficult, Dr. Sani, because you know the person who used to do, he is comfortable with that, what he's doing. So please continue, Dr. Gautam. Now,
yeah,
but we are at the slide number 12.
all right. Now it is 13, right?
No, 12. For us, it is 12.
Okay. So I think once again I
It
will
is
stop
okay.
it and I will
It is
share
okay.
it.
It is 13. It is 13 now.
Okay,
So you're doing the same manner as you did just right now. Or you share this presentation to me on WhatsApp. I will start sharing from my side.
okay.
Please continue.
All right. So now it is slide number 13, right? You can see.
Yes, yes.
Okay. So in this actually we are applying the load like this, and the some points are in tension, some points are in compression, and in this location we can paste the strain gauges, and we will get some differential output from that. So now I'm moving on slide 14. It came right? 14.
Yes. Not yet, not yet, not yet, not yet.
Okay. I think some internet problem might be there. Some slow. I guess.
Okay. So if you can share it with me, I can start from here.
Okay, sir. Okay, sir. I will share.
Otherwise, I will request my NICT. Yeah, now it is okay. Now it is 14th.
Okay, I think it's moving but slow, I guess.
Okay. No problem.
So for this measurement, we have fabricated this kind of load cell. This is double bending beam load cell, and we are applying the load here at the top using these standard weights, and we have pasted some strain gauges over the surface, and we are getting the readings on this digital indicator. So this we have done in our lab for the low range force measurement. So this is the response of the force sensor in slide number 15. So in slide number 15, we can see the force.
It is 14 only. Yeah, now it is 15.
Okay.
You kindly share it with me so that I think we can start sharing immediately.
I will share, sir.
Yeah, thank you.
Doctor, if you can click a slideshow, it would be better.
I think no. Please, you continue as you do. Otherwise, it will be difficult because we know everybody used to do in a different manner. I can understand his problem.
Okay.
Please continue.
So this is a slide number 15, and you can see the response of this transducer. So when we are applying the force up to 3 Newton, we will get a linear graph like this, and this is the reading we get at the digital indicator. So we have repeated this experiment several times and to check the repeatability, reproducibility, etc. And this response we got from this kind of load cells. So now I'm moving to slide number 16. Here we have fabricated another load cell. It is a 3D printed load cell, and here also we have pasted strain gauges in V-stone configuration. And now I'm moving slide number 17. Here you can see the load cell. This is very compact kind of load cell, and we are applying the forces using some standard weights. And the output of this strain gauges is connected to the
We
indicator.
are still at 15.
Okay, that is the problem.
Yes, now it is 16, 17.
60. Okay. So at the 17, we can see that this 3D printed load cell is the strain gauges is pasted over the surface, and this load cell is using some weights. We are applying the force, and this load cell is connected to the indicator to show the readings. So using this indicator, uh, in the slide 18, we can see the response of the force transducer. 3D printed. So this is a very compact force transducer. Hope it is moving now.
Not
Okay.
yet. It is 18 only.
So I will share this PPT, otherwise it will be difficult, I think.
Immediately, because otherwise after the, because this PPT we will also place it on our website so that the participants can see after that.
Sir, can you message me on WhatsApp? Hello?
Yes, yes.
I have shared that, sir. So I will stop sharing my PPT.
Okay.
Please share
Atulji,
from
can I
your
share
end.
it with
That
you?
will be better.
Can you do that? Is it visible to all?
Yes.
Yes, sir. Now visible slides.
Okay.
You wanted to be
So
at this
please,
slide?
yeah. Now we can move to next slide. This non-destructive
one?
testing. Yes,
Okay.
non-destructive.
Okay.
Yeah, please go before that. Yeah. So, so till now we have seen how we can measure the force using strain gauges and all. So accurate measurement force is crucial in industries, as I said before, in manufacturing, aerospace, biomedical, etc. And traditional force measurement technique often involve destructive testing using strain gauges leading to material damage, and this is the contact method. And force detection using strain gauges is generally suitable in higher range. So pasting strain gauges over the force transducer causes additional strain or stress, which causes disturbance while sensing the low force range. In addition to this, effect of pasting strain gauges is generally neglected during the simulation analysis of the force transducer. So the best way to measurement is we should have a transducer, and the measurement part should be independent from the load cell where we are applying the force. So that is the next this non-destructive testing means. So okay, please next slide. Yeah, so before going to non-destructive testing, I will talk about the speckle a little bit. What is speckle basically? So when we are uh, uh, could you please click next so that full figure can come? Yeah, when we have a rough surface, if we are illuminating it with laser, we will get the this kind of random pattern at the far field. So this is called the speckle. So why it is formed is because speckle pattern is an interference pattern that is formed when light such as from the laser light is scattered from the rough surface. So this kind of pattern is formed. It is created due to the constructive and destructive interference pattern of the scattered wave, and it is useful in metrology for measuring surface roughness, displacement, etc. So if it is suitable for measuring displacement, we can use it for the force measurement basically. And it can be observed when this laser light is scattered from the paper, metal surfaces, or biological tissue. Okay, please next slide. Yeah, please click on next. Yeah, wait here. So the speckle, it is not necessary like we have to illuminate in transmission mode. It can be also formed in reflection mode. So like that way, if we are illuminating the surface with light, the reflected light will also form the speckle pattern. So please move to next slide. Yeah. So to validate our method, whether we can able to measure the force or not, first we are uh, measuring the angle or displacement using this method, and we should provide the known value of displacement using some kind of stepper motor, so that whatever measurement we are doing, we can validate whether it is correct or not. So we have this simple arrangement here. The this a cantilever beam is there, which can rotate freely from this axis, hinged axis, and another end we have connected a stepper motor. Using the stepper motor, we can give the displacement d in steps, like in 20 micrometer steps, we can give the displacement. And we this is a metal surface, so this metal surface is uh, illuminated with a laser diode, and the reflected light is captured using a camera. And whatever image we will capture, we can, using a computer, we can analyze those images. So this is a simple setup. Please move to next slide. Yeah, and we have developed this algorithm to measure the this tilt or slope of this cantilever structure. So using this algorithm, we are doing the processing. So please move to next. So you can see at the initial stage, when there is no displacement is given, we will record a reference speckle pattern, which will look like this SP1. This is a reference speckle pattern 1. And when we are giving the displacement using a stepper motor of 20 micrometer displacement, we are recording the another speckle pattern like this SP2. And please go to next slide. Yeah, using this algorithm, we will perform the Fourier transform operation. Why we have to do Fourier transform operation is because the camera and the cantilever beam is kept at some distance away from each other. So those camera plane and object plane is connected with a Fourier transform relation. So we have to apply a Fourier transform operation on both the speckle pattern. Then we will reach at FR and FI. So please move to next. Yeah, so once we apply the Fourier transform, we will get something like this, F1 and F2. Yeah. Next slide, please. Then we have to multiply these two images, uh, and we have to conjugate, because this F1 and F2 are the complex images, complex function, you can say. They have amplitude as well as the phase. So we are interested in the phase difference. So how to get the phase differences? If we multiply one function with the another of taking the conjugate of the another function. So if we multiply like that, we will get the phase difference. And this phase we can extract, and because it is restricted to a small region, so we have to apply a cropping we have to apply, and then we have to do the resizing, and we will end up at the f psi function. So please move to next slide. Yeah, so this kind of phase information we will get. This contain the tilt of that cantilever beam. Anyway, it is still very noisy, and signal to noise ratio is very less. So we will use further algorithm to uh, improve the signal to noise ratio. So please move to next slide. Yeah. So yeah, we we will start from the f psi and we will transform using a simple transformation operation. We can make this kind of function e epsilon exponential imaginary into f psi. And if we do the Fourier transform of this function, because this function is an exponential function, it will, if we perform the Fourier transform, we will get the delta function, which will have a maximum at certain location. So from that location, we can find out the x and sy. That is the coordinate of the pixel which have the maximum intensity. And from that point location, we can get the shift. So how much speckle is shift from with respect to the reference speckle, which is undisturbed. So from that shift, basically, what we can do is we can fabricate another image which have zero everywhere, and we can assign a value to center plus this shift which we have calculated, m by 2 equal to 1. So then we will reach at this image. Please move to next slide. Yeah, so here you can see is we have this image, and at the location of this x and y, we can make the index of this value is 1. So please move one more time. Yeah, so then again we have to perform the Fourier transform operation. Please next slide. Then we will get at the f. Yeah, so and we are plotting the phase value of those. So now you can see it is very there is no noise in this image. We will get very clear image. This is the basically phase, or you can say the slope of that cantilever, but it still it is wrapped phase, not the unwrapped phase. So please move to next slide. Yeah, so we will plot the line plot, and we have to apply some phase unwrapping algorithm. So please move to next. So this is the phase we will get like this. This is a wrapped between minus pi to pi, and we have to apply some unwrapped algorithm. We will get a phase value like this, which is given in the second right side of image. So you can see this phase value now can go up to minus 35 pi. So it is not wrapped now. This is unwrapped phase, and from this unwrapped phase, we can calculate the slope value of this line. So this slope is basically equal to the slope of that cantilever. So please move to that next slide. Next. Yeah, so same algorithm we have to apply for the another images, because the displacement which we are giving, it is in 20 micrometer steps. So we can calculate, we have captured 10 images by giving 10 meter steps in each, and using the same algorithm we will get the slope value. So you can see at this is the 20 micrometer step, and then 0.04 micrometer step. Like that we can calculate the slopes, and this slope is identical to the theoretical angle. So we have repeated this experiment 2 times, and the theoretical angle is because the displacement which we are giving using a stepper motor, that is we already know. So that will give the theoretical angle, and you can measure the this measured angle is using the algorithm. So both this they are very closely matching with each other, and this validate our method, like our method is suitable for measuring the angle, or you can say the displacement. Okay, please move to next. Yeah, so now once we have validated our method, like we can measure the force value, we have designed a force transducer like this structure kind of thing, metal structure, and we have kept this force transducer over here in the next in the sorry in this image, right side image, and using a frame we have we are applying the force, and these are the calibrated weights, and the one of the beam we are illuminating with a laser, which is right corner, top corner, and the camera is connected at the left corner. So we are capturing the images. So like that way we are recording the uh, speckle pattern, and we are applying the forces using these weights. So using the same principle, please move to next slide. Yeah, we will get the response of this load cell, and you can see the we are applying the force from 0 to 5 Newton in the step of 0.5 Newton, and we will get the angle like this. So this is the response of this force transducer. So this is a non-destructive method. Okay, please move to next slide. Okay, so now the previous method is to measure the bending, or you can say the tilt. Another way is we can measure the bulging effect or deformation inside the sample using this speckle correlation technique. So what we are doing in here is we have this transparent sample, and we are illuminating it with a diverging light. So once the diverging light passes through the sample, uh, it encounter a diffuser, and the diffuser is image over this dotted line using a telecentric geometry with L2 and L3 lenses, and in between we have to kept a aperture A, which which can control the speckle size at the camera, and camera is placed at some z distance away from the dotted or image plane. So this camera is again capturing the speckle pattern. And when we are applying the force, we can change the refractive index of the sample. So by changing the refractive index, what can happen is the divergence of the beam will be different. So as you can see in the subset image, when we are applying the force, its refractive index is changing, and the divergence of the beam, initially it was at these dotted lines, and after the refractive index is changed, the light seems to come from a different point. So that that has give the different curvature of the light. So please move to next slide. Yeah, so here again we are capturing two speckle pattern, and because the previous method is valid to measure only the tilt or bending, so how can we measure the curvature now? So in order to measure the curvature which happened because of the change in refractive index, we divided the images into 10 segment, and each segment we are comparing with the another segment in the second image. So first segment we are comparing with the first segment of the first image, and we will get the tilt information in as displayed in figure D. So then we will proceed with the second segment, and we are comparing the second segment in each images, and we will again get the slope. So like that slope we are getting, and we are connecting it in figure D. And so like this way we can curvature also we can measure using this method. So this is basically speckle correlation is very powerful technique. We can measure the tilt as well as the this whole curvature. And in figure C, this is the simulated result basically, and this is the curvature we are giving, and in figure D, the curvature we are retrieving. So both are basically matching with each other. So this confirm that using this speckle correlation technique, we can measure the curvature also, like bulging effect also. Okay, please move to next slide. And these are the results we have published in applied optics. Uh, yeah, please move to next slide. Yeah, this is another paper we have published in experimental techniques. Another, yeah, and one more we have published in conference paper FIO LS, which happened in United States. Yeah, please move to next slide. Yeah, thank you very much for this.
Thank you, Dr. Gautam, for this beautiful presentation. And I think that it is very important. But we would like to understand how we are doing the load cell testing, how we are actually calibrating the load cells and the torque
Okay.
machines. It will be very useful for all the participants, because this force and the top technology is very important. Nowadays, as we are
Yes,
all
sir.
aware, the primary standards are very few in the country. So how to
Yes, sir.
develop a primary standard, how a load cell can be used as the primary standard, these are the most important things which our participant would like to understand. I would like to request you, as you have already shared this presentation, this PPT
Yes, sir.
as well as the video will also be available on our website. But my request is you kindly make a PPT in such a way by which we can
Okay.
explain how the people are doing in their laboratories, what are the best practices, and how they can do the, giving the Excel sheets, how they can get the results directly. This is very important because nowadays everybody is using the Excel sheets. Yes, I think somebody
Yes, sir.
wish to ask the question. Please.
Thank you, sir. Further to Dr. Ashutosh, sir, I would request Dr. Surya to incorporate, like, for force calibration, what are the different parameters for the uncertainty calculations? Those are very
Okay.
important parameters.
Yes,
Like
sir.
as per ISO 376, ISO 7500 Part 1. So we would like to get some information from reputed organization like NPL and all. So that
Yes,
would be a great opportunity to get some information on force calibration for industrial as well as primary.
yes, sir. Sure, sure, sure. I will include those things in my talk next time, maybe. I Yesterday actually, I some student visit is there in NPL, and I have shown that real demonstration to them, and they were very interested. I was forget to record that whole procedure. Otherwise, I could have included that in this today's
No,
talk.
if you have a small video, you can share it. How the participants, how we are doing the calibration. It will be more important than anything else.
Yeah,
Yes, sir.
but
For
right now I
industrial
don't have.
application.
Yeah, maybe next time. Sure, sure. I will do that.
Thank you.
I
Thank
would
you,
like to
Dr.
request all the participants to kindly switch on their video so that we can take few photographs for the social media platforms. My request is kindly visit our website on regular basis. This Jago Grahak Jago .gov.in/seminars, where we mention the new programs as well as all the certificates of all the training programs are already there. Anybody can find any of the certificate which he or she has participated. With this, I would, Atulji, have you taken the photographs?
Yes, sir. We have taken.
Thank you. I would like to thank Dr. Gautam and my participants who have given their time to understand what we are doing. But my request is from the very next time, we will try that it should be more, interactive type, and how we are doing the calibration, how we are actually calculating the uncertainties. Because with the help of the Excel sheets, nowadays, nobody is going in a complete detail how to calculate one by one
Yes,
each para. But to put
yes,
put the data in the Excel sheet and get the results. So these are the requirements of time. And I think that as India is developing very fast, we are becoming the next, economy of the world, and we are actually working for this technology in a very great manner. I hope that most and most laboratories are required in our country who are actually doing the calibration. Thank you very much. With this, I would like to thank all the participants. Thank you very much. We will meet in the next week with the next program. Thank you, sir. Thank you. All the best. Bye-bye. Good day.